Good morning, students. In the previous session, you have learned tangents and normals and increasing, decreasing function concepts and few problems based on those two concepts. So today in this session, you're going to learn the maxima, minima. This is one of the most important concepts in the calculus. Okay. So before going to maxima, minima, you need to understand the concept of increasing and decreasing function, which was learned yesterday. So just we'll revise once again the few points of the increasing, decreasing function. In the previous class, you have learned one second. In the previous class, you have learned f dash x greater than 0. That means the dy by dx is greater than 0 in a given interval. We say that the function is increasing in the closed interval a. Similarly, if the f dash x is less than 0, I mean dy by dx is less than 0, or you can say slope is negative, the function is decreasing function. If f dash x equal to 0, we will say that the function is a constant function or the tangent drawn parallel to x-axis. These are the concepts you have learned yesterday. We use these concepts to continue further. Now in the maxima and minima, you need to understand what are the turning points or stationary points. Here, if you observe this graph, a function, the graph is increasing up to a and ceases to increase at point A and begins to decrease, and decreases up to point B and ceases to decrease and again begins to increase. So the point A is a turning point. It is ceases to increase and begins to decrease. The point B is ceases to decrease and begins to increase. So these points are called turning points. So how to define those turning points? A function f of x is said to have attained maximum. So this maximum point and these minimum points are called turning points here. Okay. A function f of x is said to have attained maximum at x equal to a if the function ceases to increase and begins to decrease. And the function f of x is said to have attained minimum if the function ceases to decrease and begins to increase. So at point A, it is ceases to increase and begins to decrease. Thereby, we say it is a turning point of maximum. And at point B, it ceases to decrease and begins to increase. Thereby, this turning point is a minimum point, we say. So now in the interval a to b, the function is a decreasing function. In the interval a to b, the function is decreasing function. Similarly, if you see the second graph, a to b, it is a decreasing function, and b to c, it is an increasing function, and again c to further, it is a decreasing function. Right. So at a, point B and at C, the status of the curve is changing from one state to another state. At point A, the status of the curve is changing from increasing state to decreasing state. At point B, the status of the curve is changing from a decreasing state to increasing state. So when the status of the curve is changing from one state to another state, that point is called a turning point or stationary point. Those points may be maximum points or minimum points, or we may call these points as local maxima and local minima also. Local minimum values. Is this concept is clear? The turning point means the status of the curve changes from one state to another state. Maybe increasing state to decreasing state, or maybe decreasing state to increasing state. Those points are called turning points. These turning points may be a maximum point or minimum point. Okay. Now, you need to understand these turning points are maximum and minimum point. It doesn't mean that they are the greatest and the least values of the function. Doesn't mean that they are the greatest and the least values of the function. They only signify that these values are greater or less with reference to its immediate neighborhood. It's a greater or less value with reference to its immediate neighborhood. Here, a function can have any number of maximum and minimum values. That means a function can have any number of turning points. If you observe this graph, you have point P, Q, R, and S. All these points are turning points. And if you observe this curve, again, these turning points occur alternatively. That means two maximum points or two minimum points do not occur consecutively, successively. Okay. And at the same time, if you observe the minimum value, a minimum value can be greater than the maximum value. If you observe this graph, a point P is the maximum point because the status of the curve is changing from increasing state to decreasing state. And if you observe the point S, the point S is a minimum point. The status of the curve is changing from decreasing state to increasing state. So thereby S is the minimum point. The minimum point S value is greater than the value of the maximum point at point P. So that is the reason we say they are not the greatest and the least values. With reference to its neighborhood, we say that they are the maximum or minimum values. Yeah, is it clear? Yeah. Now, what are the conditions for maximum and minimum? So now, just now you have learned the first condition is the status of the curve changes from one state to another state. We'll go back to the previous slide. When the status of the curve changing from one state to another state, so now here if you observe, the status of the curve is increasing state to decreasing state. In the previous class you have learned when the curve is increasing, dy by dx is greater than 0. When the curve is decreasing, the dy by dx is less than 0. Isn't it? That means when the status of the curve is changing from increasing state to decreasing state, the slope changes from a positive to negative. This concept you need to understand very clearly. See, when the status of the curve is changing from a positive to negative, when the status of the curve is changing from increasing state to decreasing state, correspondingly the slope is changing from positive to negative. In the process it is changing from positive to negative, it has to pass through 0. The dy by dx must pass through 0. Similarly, at point Q also, if you observe, at point Q, it is changing from a decreasing state to increasing state. Again, when it is a decreasing function, dy by dx is less than 0. For an increasing function, dy by dx is greater than 0. So that means, again, if the function status is changing from a decreasing state to increasing state, correspondingly the slope is changing from negative to positive. So in the process, when the slope is changing from negative to positive, it has to pass through, it has to move through 0. It has to pass through 0. Okay. Now same thing we have noted down in the next slide here. So at a maximum point, the function y is equal to f of x changes from increasing state to decreasing state. That means dy by dx changes from positive to negative. In the process, the dy by dx changing from positive to negative, it must pass through the value 0. So that means at dy by dx equal to 0, the function attains maximum. That means at dy by dx equal to 0, the point is a maximum point. Similarly, at a minimum point, the function y is equal to f of x changes from a decreasing state to increasing state. In the process, it is changing from decreasing state to increasing state. Correspondingly, the dy by dx changes from negative to positive. That means a dy by dx must pass through 0. So, at minimum point also dy by dx equal to 0. At minimum point also dy by dx equal to 0. And we found out for a maximum point also dy by dx equal to 0. Minimum point also dy by dx equal to 0. That means, so dy by dx equal to 0, slope equal to 0 means that point may be maximum point or maybe minimum point. And since you have learned yesterday a simply increasing function and a strictly increasing function, so dy by dx equal to 0 means it is a constant function, maybe an increasing function and decreasing function also. That means it not necessarily maximum or minimum also. It is only necessary condition, but not sufficient condition to say it is a maximum point or minimum point. So if dy by dx equal to 0 means maybe maximum or maybe minimum or maybe something else or maybe constant function at that particular point. Okay, that means dy by dx doesn't mean that the function necessarily increases, attains maxima or minima. It is one of the conditions. So then what is the second condition? Okay. So before going to the second condition, just now you have noted down that the dy by dx means the function ceases to increase and begins to decrease, or ceases to decrease and begins to decrease, but not necessarily change the status of the curve. So if you observe this graph, here the dy by dx equal to 0 and the status of the curve is not changing. Again, it is going on increasing. Similarly, here the status of the curve is dy by dx equal to 0. The status of the curve is not increasing. Again, it is going down. It is decreasing state. So dy by dx equal to 0 means maybe increasing function, maybe decreasing function, or it is may not be, not necessarily the status of the curve changes from one state to another state. That means in the third case, we say it is called a point of inflection. When the status of the curve do not changes from one state to another state and dy by dx equal to 0, then we say that it is a point of inflection. That means actually what in this increasing state, dy by dx changes from positive to 0 and again 0 to positive. It is not changing from 0 to negative in this case. Similarly, in this case, it is changing from negative to 0 and 0 to again it's negative. If it is changes from 0 to positive, it is a turning point. Since it is not changing from 0 to positive, it is 0 to negative, once again it is going. Thereby, it is called a point of inflection. Okay. Now, this point of inflection is deleted from the reduced syllabus for this academic year. This concept is excluded. Okay. Now, what is the sufficient condition for maxima and minima? For a maximum point, already you have learned that dy by dx changes from a positive to negative. dy by dx changes from a positive to negative. For a minimum point, a dy by dx changes from a negative to positive. Dy by dx changes from negative to positive. So that means what? For a maximum point, dy by dx equal to 0, and dy by dx changes from positive to negative. For a maximum, what is the condition? One of the condition is a dy by dx equal to 0, and the status of the curve should change from a positive to negative. Okay. For a minimum point, again dy by dx equal to 0. This is a common condition, and the dy by dx must change from a negative to positive. Okay. Then how to make it is a mathematical concept. This is how to write this is by modifying it. So for a maximum point, a dy by dx changes from positive to negative. That means when you consider dy by dx itself is another function z, this z is a decreasing function. This z is a decreasing function. For a function z decreases means its derivative must be less than 0. That is dz by dx, or we can say d square y by dx square must be less than 0. Since the function z is decreasing, its derivative must be less than 0. Similarly, for a minimum point, the dy by dx changes from negative to positive. That means a dy by dx is increasing function. When you consider a dy by dx is another function z, this z is increasing function. For an increasing function, its derivative must be positive. So what is the derivative of z? The derivative of z is dz by dx. The derivative of z is dz by dx, which must be greater than 0. dz by dx is nothing but the derivative of dy by dx, that is a d square by dx square, which must be positive. So when you combine these two conditions, the necessary and sufficient conditions, the dy by dx equal to 0, and the second derivative is negative, to say the function attains maximum. If dy by dx equal to 0 and its second derivative is positive, we say the function attains minimum. Is it clear? For the maxima and minimum. For maxima and minima, for both the cases, the derivative must be equal to 0. And for maximum point, the second derivative must be less than 0, I mean negative. For a minimum point, the second derivative must be greater than 0. That means it is positive. Now, how to find a local maxima and minima? A working group. First, you need to identify the function, or sometimes in the question they give directly the function. You need to differentiate the function and find out dy by dx. Dy by dx to be calculated. You need to differentiate the function and equate to 0. And equate to 0. Find the values of x by solving dy by dx. Find the values of x by solving dy by dx equal to 0. So these points may be maximum or minimum, may be point of inflection. We don't know. Maybe maximum point or minimum point or point of inflection. How to identify the point is maxima or minima or point of inflection? For which a second derivative test, that's called, you need to differentiate the function once again and verify that the value of the second derivative at that particular value of x is a positive or negative. At that particular value of x, if the second derivative is negative, then we say the function attains maximum at x equal to a. That f of a is maximum value of the function in such case. If The second derivative is negative. At that particular value of x equal to a, we say that the function attains minimum and the f of a is a minimum value of the function. I hope you understood this concept. So this is the method of finding a local maxima and local minima. Now we'll solve few problems based on these concepts so that the concept becomes very clear to you all. Okay. Okay, given that the function f of x is equal to 3x to the power of 4 plus 4x cubed minus 12x square plus 2. Find the critical points. Critical points means turning points of the function f of x. Use the second derivative test to label them as the relative maxima or minima. Okay, so what is the working rule? You need to differentiate the given function first. 3x to the power of 4 plus 4x cubed minus 12x square plus 2. Now, if you differentiate, you get f dash x equal to 3 into 4x cubed, that is a 12x cubed, plus 12x square minus 24x. After differentiating, what we need to do? You need to equate to 0. When you equate to 0 the first derivative and simplify further, you get 12x if you take common, x square plus 1 x minus 2 equal to 0. 12x into x square plus x minus 2 equal to 0. If you factorize x square plus x minus 2, again you get x minus 2 into x plus 2 into x minus 1. So you can write down 12x into x plus 2 into x minus 1 equal to 0. It implies that you get the values x equal to 0 or 1 or minus 2. So you need to verify at each value of x, is it a maxima or minima? First, they ask to find the critical points. Critical points means you need to find the corresponding value of y. Y is nothing but your f of x. At x equal to 0, f of 0, that is y, is equal to, if you substitute in the function x equal to 0, y equal to 2 you get. That means one of the point is 0, 2. At x equal to 1, f of 1 equal to 3 plus 4 minus 12 plus 2, that is 3 plus 4, 7 plus 2, 9, that is 1 comma minus 3. At x equal to minus 2, f of minus 2 is equal to 3 into minus 2 to the power of 4, that is 16, plus 4 into minus 2 cube, so minus 8, minus 12 into minus 2 square, that is 4 plus 2. To simplify, 48 minus 32 minus 48 plus 2. So you get minus 30. So the other point is minus 2 comma minus 30. So we found out the critical points. You need to label them by using the second derivative test, which point is a maximum point or minimum point. For which what we need to do? You need to differentiate once again. So f dash x is equal to 12x cubed plus 12x square minus 24x. Differentiate once again. f double dash x, or d square y by dx square. That is equal to 36x square plus 24x minus 24. Okay, at x equal to 0, what is f double dash x? Minus 24, isn't it? That means the second derivative is less than 0. If the second derivative is less than 0, so this is the point, corresponding point 0, 2 is a relative maximum point. Okay. At x equal to 0, the function attains maximum. The maximum value of the function is 2. Okay. Now at x equal to 1, at x equal to 1, f double dash x equal to 36 plus 24 minus 24, which is greater than 0. The second derivative is positive. That means the function attains minimum. So the function attains minimum at x equal to 1, and the minimum value of the function is minus 3 in this case. We'll verify at x equal to minus 2 also. At x equal to minus 2, f double dash x equal to, so minus 2 square, 4, 36 4s are 144. 24 into minus 2, minus 48, minus 24. So again, it is a positive. F double dash x is positive. That means the function attains a minimum at x equal to minus 2. If you draw a number line, you can understand this is 0 and 1 and minus 2 if you take on the number line. You can verify whether these maxima and minima occurred alternatively or not. At point 0, the function attains maximum. At 1, the function attains minimum. At x equal to minus 2, the function attains minimum. If you observe, these points are occurring alternatively. So first at minus 2, it is a minimum, and at x equal to 0, it is a maximum. At x equal to 1, it is again minimum. So thereby, you can understand that once again, the maxima and minima points occur alternatively. Okay. This is the method of solving identifying or finding the maxima and minima values. Okay. We'll go to the one more question. A word problem. A rectangular storage area is to be constructed along the side of a tall building. A security fence is required along the remaining 3 sides of the area. What is the minimum area that can be enclosed with 800 meters of fencing? Here, if you read the question carefully, a rectangular storage area to be constructed along the side of a tall building. So now you have considered this is the tall building. This is the tall building, if you say. And a security fence is required along the remaining 3 sides of the area. So remaining 3 sides. Now what is the maximum area that can be enclosed with 800 meters of fencing? That means from whenever the word problem is given, you need to identify first what is the function. So what is the maximum area? So that means you need to verify the area of the function. So that is the area is the function in this case, because you need to find the maximum area. So the function is area of the rectangular storage. So when you consider the dimensions are X and Y units, then what is the area of this rectangular storage? X into Y. The area A is equal to X into Y. There are two variables X and Y in this case. So before processing the problem, differentiating the problem, you need to rewrite in terms of one variable with the help of the given information. What else is the given information? The enclosed with 800 meters of fencing. Enclosed with 800 meters of fencing. That means the sum of these two sides and this side together 800 meters. That means given that the 2x plus y equal to 800. With the help of this relation, write down one variable in terms of other variable. So now you can write down y is equal to 800 minus 2x. Let's substitute this result in the function area. That is x into 800 minus 2x. If you simplify further, you get 800x minus 2x squared. 800x minus 2x squared. So now after identifying the function in terms of one variable, what is the first step we need to do? Differentiate the function, just like in the previous problem. So what is the major difference between the previous problem and in this problem? In the previous problem, they are given the function directly. You have differentiated and you have completed the problem. Whereas in this case, you need to identify the function and you need to formulate what is the function. Mathematical expression to be formulated. Now dA by dx is equal to, when you differentiate it, 800 minus 4x. If you equate to 0, you get x equal to 200. X equal to 200. At x equal to 200, is the function attains maximum? Area attains maximum, for which you need to verify once by differentiating second time. Differentiate once again d square a by dx square. So which is equal to minus 4. Which is less than 0. Since the second derivative is less than 0, the function attains, area attains maximum at x equal to 200. When x equal to 200, what is the value of y? Value of y equal to 800 minus 2x. This is the relation now. 800 minus 2x, that is 400. Y equal to 400. The question is, find the maximum area. There will be the maximum area of the rectangular portion is x into y, that is equal to 200 into 400, that is equal to 80,000 square meters. Is it clear? So the word problem to be solved in this fashion. First, you need to identify the function by reading the question carefully and rewrite the function in terms of one variable, then follow the process. Okay. We'll solve one more problem based on the same concept. Okay. Show that a circular cone of maximum volume inscribed in a sphere of radius A is 8 by 27 times of volume of sphere. If you read the question carefully, what is the given information in this case? A sphere of radius A units. That means, let's say O is the center of the sphere. O is the center of the sphere. So that means, and if you say this is the point A and B, now this A, B, C, this is a cone inscribed in a sphere. The edges of the cone touches the sphere at point A, B, and C. If you drop a perpendicular from A to the base of the cone, say AM, which is equal to height of the cone. Let us consider R is the radius of the cone. Okay. Now, since radius of the sphere is equal to given that A units, what is the volume of sphere? What is the volume of sphere? Volume of sphere is equal to 4 by 3 pi A cube. Since in this case radius is equal to A. Okay. Now we are considering that the radius of cone, which is inscribed in a sphere, equal to R units, and height is equal to H units if you consider. Here we know OA equal to OB equal to OC equal to radius of the sphere, that is A units. And we have considered AM is the H units, which is the height of the cone. Thereby, what is OM is equal to? This OM becomes H minus A. OM becomes H minus A. Now consider the triangle OBM. In the triangle OBM, if you apply the Pythagoras theorem concept, OB square, that is A square is equal to R square plus A minus H minus A whole square. R square plus H minus A whole square. When you simplify further, you get A square is equal to R square plus H square plus A square minus 2AH. A square gets eliminated. You get R square is equal to H square minus 2AH. This is the one relation to be remembered. Okay. Now, show that a circular cone of maximum volume. Here, a circular cone of maximum volume. That means the volume of cone is your function. So what is the volume of cone? Since you have considered R is the radius and height is the H, 1/3 pi R square H is the volume of cone. In the volume of cone, there are two variables, R and H. With the help of this given relation, rewrite in terms of one variable here. That is 1/3 pi H into R square equal to H square minus 2AH. That is equal to 1/3 pi H cube minus 2AH square. So now you have found out the volume function, volume of a cone in terms of one variable H, that is. Now differentiate this dV by dH. When you differentiate this volume function in terms of one variable, in terms of variable H, 1/3 pi remains the same. The derivative of H cube, 3H square minus 4AH. And after differentiating, what we need to do? We need to equate to 0. When you equate to 0, you get H, if you take common, 3H minus 4A equal to 0. It implies that h equal to 0 or h equal to 4a by 3. H equal to 0 is not possible. When h equal to 0, you cannot form a cone. So this is the absurd solution. You can ignore it. Now h equal to 4a by 3. At h equal to 4a by 3, you need to verify whether the volume of cone is maximum or not. For which what we need to do? Need to differentiate once again the volume function. That is a d square v by dh square. That is a 1/3 pi. 3h square differentiation, 6h minus 4a. You need to verify at h equal to 4a by 3, is this second derivative is a positive or negative? For which a d square v by dh square equal to 1/3 pi into 6 into 4a by 3 minus 4a. So what is the value you get? 1/3 pi. 3 2s. You get 8a minus 4a. That is a minus 4a, which is less than 0. So we identified that the second derivative is negative. Since second derivative is negative, the volume of cone is maximum at h equal to 4a by 3. So we verified that the volume of cone is maximum at h equal to 4a by 3. Now you need to prove that the volume of cone is equal to 8 by 27 times of volume of sphere further. Okay. Now we noticed that we found out h equal to 4a by 3, and the volume of cone, we'll go back to the previous slide. The volume of cone is equal to 1/3 pi h cube minus 2ah square. One-third pi h cube minus 2ah square. Isn't it? Now, the volume V is equal to 1/3 pi Now, what is h cube? H is equal to 4a by 3. 4a by 3 whole cube. That is 64 a cube by 4 is a 16, 927 minus 2a into h square. H square equal to 16a square by 9. So volume V is equal to 1/3 pi 64a cube by 27 minus 32a cube by 9. So volume V equal to 1/3 pi. Take LCM 27 the 64a cube minus 332 96a cube, that is equal to 1/3 pi into 32a cube by 27. So this is a error I have made here. This is a plus. Here also, this is a h square minus r square equal to, this is a plus 2ah minus h square. Okay. Yeah. So that means we get this is so there is a minus sign. Right. Now, since volume V equal to, we obtained 1/3 pi 32 a cube by 27. So this can be written as this 4 by 3 pi a cube into, is it 8 by 27? So 8 fours are 32 pi a cube by 27 into 3. So that means what is 4 by 3 pi a cube, which is nothing but the volume of sphere. So now volume of cone is equal to, we have written as 8 by 27 times of volume of sphere. Yeah. We'll go to one more question. Find the dimensions of the largest rectangle that can be inscribed in a circle of radius a units. Circle of radius a units. Here, O is the center of the circle. If we join AC in this diagram, AC must pass through O because ABCD forms a rectangle. Since given that ABCD is a rectangle, angle B is a right angle and angle D is a right angle. That means the diameter subtends a right angle on the circumference of a circle. This is the concept you have learned in the 10th class. So thereby, since angle ABC equal to 90 degrees, the AC must be diameter. The diameter always pass through center of the circle. Here given that the radius of the circle is equal to A units. Since OA equal to OC equal to A units, the diagonal of the rectangle AC equal to 2A units. Okay. Let us consider the dimensions of the rectangle. AB is equal to X. AB is equal to, we'll consider 2X for convenience sake. And BC is equal to Y. Find the dimensions of the largest rectangle. The largest rectangle will have maximum area. That means, what is the function? Area of the rectangle is the function. Area of the rectangle is 2x into y. There are two variables, x and y. You need to reduce it into only one variable with the help of the given information. What is the given information in this case? We found out AC equal to 2A. And AB is equal to, we considered 2x units, and BC equal to y units we considered. So when you apply the Pythagoras theorem, 4a square is equal to 4x square plus y square. 4x square plus y square. So from this equation, you can find out y square is equal to 4 times of a square minus x square. Isn't it? Now, what is y equal to? 2 into the root of a square minus x square. Substitute this value and reduce area in terms of only one variable. Now, area A equal to 2x into 2 into root of a square minus x square, that is equal to 4x into the root of a square minus x square. See, you can differentiate this area function as it is, or if the area is maximum, its square is also maximum. For convenience sake, I will take its square of the area and differentiate. So let us say the function z is equal to a square. I'm taking the square of the area, that is 16x square into a square minus x square. So that is 16 into a square x square minus x to the power of 4. Differentiating this is more comfortable. So now differentiate dz by dx is equal to 16 times of a square into 2x minus 4x cubed. If you equate to 0, what you get? Two x if you take common, a square minus 2x square equal to 0. X equal to 0 is not possible. So it implies that the next possibility is 2x square is equal to a square. Or you can say x square is equal to a square by 2. Or x equal to a by root 2. I'm ignoring the negative value. X equal to a by root 2 obtained. At x equal to a by root 2, is area of the rectangle is maximum or not? For which differentiate once again. D square z by dx square. That is 16 into a square into the derivative of 2x, 2 minus 12x square. So at x square is equal to, if you substitute a square by 2, 16 times of 2a square minus 12 into a square by 2, that is less than 0. Since second derivative is less than 0, the area of the rectangle is maximum. Area of rectangle is maximum. At when x is equal to a by root 2. When x equal to a by root 2, the question is find the dimensions. So that means you need to find the value of y. So y is equal to 2 into root of a square minus x square. That is 2 into a square minus x square, a square by 2. That is equal to 2 into 2a square minus a square by 2 under root. That is equal to 2 into a by root 2. Y equal to, that is nothing but root 2 times of a. Y equal to root 2 times of a. What is y? Y is equal to BC of the rectangle. Then what is AB? AB is equal to 2x. That is equal to 2 into a by root 2. So that means that is also equal to root 2 times of a. So that means we noticed that AB is equal to BC. AB is equal to BC. We found out the dimensions of the rectangle. That is AB equal to BC equal to root 2 times of A. So what is the inference you can draw from it? The largest rectangle which is inscribed in a circle is not a rectangle, it is a square of side root 2 times of A. Yeah. We'll move on to one more question. Prove that a conical tent of a given capacity will require the least amount of canvas when the height is √2 times radius of its base. Consider this vertex is A and the center of the base circle is equal to O and is a point B if you consider. We know the relation between radius, height and slant height of the cone. R square plus H square is equal to L square. So here what you need to prove? The conical tent of a given capacity. It's a given capacity. What is the meaning of capacity? Which is a volume. Volume of cone is given. The volume of cone is equal to 1/3 pi R square H is the volume of cone. That is a given. Will require the least amount of canvas. Least amount of canvas. That means a minimum length of the dimensions of the canvas. So minimum canvas means the surface area of the tent should be minimum. Since it is a tent, we will take only curved surface area of the tent. What is the curved surface area of the tent? CSA. Simply I will call it surface area equal to pi RL. So now from this relation, here there are two variables R and L. With the help of the relation R square plus H square is equal to L square, you can write L is equal to under root of R square plus H square. So thereby the surface area S can be written as pi R into under root of R square plus H square. Just like in this previous problem, since there are two variables and square root, we'll squaring on this surface area, say Z is equal to S square is equal to pi square R square into R square plus H square. There are two variables R and H. We know that one more relation given here, volume V is equal to 1/3 pi R square H. With the help of this relation, we can say R square is equal to 3V by pi H. 3V by pi H. If you substitute 3V by pi H in this pi square, R square, that is a 3V by pi H into 3V by pi H plus H square. So now simplify further. So that is equal to pi square 3V by pi into 3V square by pi H square 3V square by pi H square. This 3V also have taken common. So now 3V by pi H square plus H square by H. That is equal to H. This is your function Z. If you differentiate this function Z, with reference to h, dz by dh is equal to, so 1 pi gets eliminated. You get 3v pi times of 3v square by pi will be remains same into 1 by h square. The derivative of 1 by h square is minus 2 by h cube plus the derivative of h is equal to 1. If you equate to 0, you get the result 3v square into 2 by pi h cube equal to 1. If you simplify further, pi h cube is equal to 6v square. Pi h cube is equal to this v square. No, this is not v square. This is only v only. The v not multiplied. 6v. Pi h cube is equal to 6v. What is volume V equal to? 1/3 pi r square h. So now pi h cube is equal to 6 into 1/3 pi r square h. If you simplify, pi gets eliminated. 1 h gets eliminated. H square is equal to 2r square. It implies that h is equal to √2 times of r. We found out h is equal to √2 times of r. But at h is the surface area is minimum or not to be verified, for which you need to differentiate once again. We'll differentiate the function once again. D square z by dh square. So that is equal to 3v pi into 6v minus 6v by pi into this 1 by h cube. This is the first derivative. No, we have to differentiate this. 1 by h cube derivative is minus 3 by h to the power of 4. The derivative of 1 equal to 0. So if you observe this minus of minus plus, so thereby altogether at h is equal to √2r, at h is equal to √2r, the d square z by dh square is greater than 0. The second derivative is positive. Since second derivative is positive, the surface area of cone is minimum. We can say the surface area of cone is minimum. Surface area of cone is minimum means what? We need least amount of canvas is required. So when h is equal to √2 times of r. So if you see the question, prove that the conical tent of a given capacity will require the least amount of canvas when height is equal to √2 times of radius of its base. So we found out that at h is equal to √2 times of r, the surface area of cone is minimum. That means least amount of canvas is required when height is equal to √2 times of radius. Is it clear? Yeah. So with this, we'll conclude the session. And assignment 2, I have given this assignment, and note down these problems and practice it. And I will try to answer a few questions which have come across right now. I may not be able to answer all your questions due to time constraint, and whatever the questions, rest of the questions will be answered and will be put up in the council's website, and subsequently you can go through it. Yeah, so this is first question. Can you explain about a closed interval AB and open interval AB? Yeah, and most of the students in the examination, they get confusion about this a closed interval and open interval. While doing the mean value theorems, Lagrange's mean value theorem and Rolle's theorem, you people generally commit mistakes by writing this closed interval and open interval. The closed interval AB, that means both the values, both the extreme values are included. Suppose that means if you say X belongs to AB, it implies that A less than or equal to X less than or equal to B. X can be any value from A to B inclusive of A and B. That's called a closed interval. Then open interval. The open interval is represented by a parenthesis. A closed interval is represented by a square bracket. So now X belongs to a open interval AB implies that A less than X less than B. All values of X in between A and B, excluding the extreme values, that is called open interval. If you include the extreme values, it becomes the closed interval. If you exclude the extreme values, it becomes the open interval. The closed interval is represented by a square bracket. The open interval is represented by parentheses. Is it clear? I hope you understood the basic difference between the closed interval and open interval. Yeah? We'll go for the next question. We'll wait. The next question is, can a function have two maximum values or two minimum values consecutively? So today, right now, we discussed about this point. A function cannot have two maximum values or two minimum values consecutively. These maximum values or minimum values occur alternatively always. If you take the number line, if you say these are the values of x1, x2, x3, x4, suppose if you identify at x equal to, at x2 it is a maximum value, immediately you can identify its next value is a minimum, its next value is maximum. Similarly, in the preceding, the value is minimum, so on. So the maximum and minimum values always occur alternatively. They never occur consecutively. Is it clear? We'll go to the next question. Can you explain about working method of solving word problems of maxima and minima concept? Yeah, this is also today we discussed. In the word problem, we solved 2-3 problems also today. In the word problem, first you need to read the question carefully. Read the question carefully, and you need to synthesize the question, and you need to separate the information into two parts. One is, what is the given information? Given information means what are the clues given to solve the problem, and what is need to be calculated. What is need to be calculated or identified. Okay. Now, when you separate into two parts, the given information and what is need to be calculated, and establish the relations between the given information and what is need to be calculated. To establish the relations, you need to have the entire concept. Okay. By establishing the relation between the given information and what is to be calculated, identify the function first. How to identify the function? So you need to verify in the problem what is maximum, what is minimum. If they say the volume of the function is maximum, that means the function is your volume. After identifying the function, you need to rewrite the function in terms of one variable. With the help of the given information. With the help of the given information. After writing in terms of one variable, the next part is common. Differentiate the function and equate to 0. Find the values of x, find the values of variable x. At each value of x, verify that the second derivative is positive or negative. If the second derivative is positive at a particular value of x, the function attains minimum. At a particular value of x, if the second derivative is less than 0, the function attains maximum. This is the process to be followed. This is the broad concept of solving the problem of maximum. I hope it gives total clarity about the method of solving the word problems. Okay. I'll wait for the next question. Oh, this is today's last question for this session. Can you explain about the weightage of the calculus in the board examination? So in the board examination, the calculus is having a greater weightage. If you observe the syllabus, the section A consists of a 32 marks weightage. Section A consists of a 32 marks weightage. And in the section B, it is a 4 marks weightage. 4, I don't remember exactly, 4 or 5. 4. A section C, the weightage is 5 marks. So altogether, section A and B together, it is a 36 to 37 marks weightage of calculus in the board paper. So that means almost you can say about near about 50% out of 80 marks. Out of 80 marks, 50% of the syllabus is calculus. Okay, you cannot ignore the calculus. while attempting the board paper. So in this 50%, or in section A, 32 marks. So yesterday's session and today's session, you have learned application of derivatives. On the application of derivatives, you have learned the tangents and normals, increasing, decreasing function, and maximum and minimum. These three concepts may cover about 10 marks weightage. Around 10 marks weightage, plus or minus 1 or 2 or 3, that side or this side. It covers 10 marks weightage. Is it clear? I hope this gives a total clarity about the weightage of the calculus of the board examination. So this calculus cannot be ignored at any point of time to get a very good score in the board examination. With this, we'll conclude the session. So I wishing you all the best, children, and prepare well for the examinations. And I thank Council for taking initiation to conduct this virtual learning series. And I thank everyone who watching this session. Thank you all.